All right, boys and girls, let's do this. Listen, Diego, focus. Thank you. That's okay. Brandon. I know you like the challenge, but let's go over this together. You ready? Okay. No, you said. Too bad. Here we go anyway. Somebody said no. I don't know. Okay, so first of all, you have to make sense of what you already know and apply it to these things. I won't give you a problem that's inaccessible. Everybody knows what they need to know right now to answer all of these. But you have to not look at it and go, oh my gosh, I'm freaked out, what do I do? You don't think, what do I do? That's not what you think first. You first think, well, what do I know? So like, I don't know, there were a few people who came and asked me for help. They're like, I don't know what to do. And then I asked them to like describe what kind of problem that is. And eventually, after about 5 minutes, they were able to say, oh, that's a fraction. I'm subtracting fractions. To subtract fractions, I need to find a common denominator. That's it. That's the key piece of information. That's it, right? So the common denominator for this one's going to be x squared y because that is the lowest common multiple, right, of x squared and of y. So Parth, the thing that's missing from this one to make this x squared y, to make this into that is just, oh yeah, sorry, x squared. I was reading and then talking and then, yeah. X squared, yeah. So that's going to be, whoa, what's x squared times 3x? 3x cubed. Okay, now, minus. We're missing a y over here, that's 2y squared. Are we good so far? Can it be reduced?
No.
Oh, no. Whoa, wait. Allison, that cannot be reduced?
No.
Why not?
Because the 2 doesn't have an x, and the 2y squared doesn't have an x, and the 3x cubed doesn't have a y.
So this has an x and a y, correct? Here's what and so in order for this to be reduced, this would have to have an x and a y, and so would this. This has a y, no x. This has an x, no y. They don't all have a common factor, so you can't reduce. So you're done. Okay. Next one's kind of ugly, but check it out. 3 goes into 9, yeah? They both have an a squared, so that's beautiful. You don't do a to the 4th. You don't just multiply these together. That's like, no. And then this is missing a b squared, but they both need a b squared, right? So actually this one's kind of not so bad. This one's actually easier than the first one. It's got more stuff, but it's easier. Because look, all I need to do to change this to be the common denominator is multiply by b squared. So 3ab squared. Okay. So easy a caveman can do it. So there's hope. There's hope. Brandon, what's your question? We're not done yet, Brandon. That's okay. I need to take, wait, what's this missing? 3? This is missing a 3 because it's got 9, right? So 3 and 3, so that's... Brandon says we can reduce this. Do you agree or disagree?
I agree.
You agree? Samantha, you agree? There's 3 terms, 2 on the top, 1 in the bottom, and they have something in common? What is it that they have in common?
3.
A 3? Oh my gosh. A 3b? Oh no. So I can divide a 3b out of everything?
Yes.
A la bestia. Whoa. This is weird. Dang. Okay, check this out. If I take a 3b out of this, I'm left with 3ab, yeah? And then minus 1?
Yes.
1.
You have to take out the 3.
You have to take out the...
Yeah, you have to take out the 3.
AB.
Because you divide by 3.
Oh,
Yeah.
I'm sorry, yes. So ab minus 1. Yes, Jesus?
So like, I'm confused about the 1. I don't know if it's...
Because you're dividing out 3b. What's 3b divided by 3b? 1. So it's just 1. 3a squared b, is that right? Is that right? Okay. There was something super simple you guys missed at the very beginning that would have made your life even easier. And here is your clue. If you get a lowest common denominator and you add or subtract and then you can reduce, that means you didn't actually find the lowest common denominator. We did not find the lowest common denominator because this can be reduced.
Yeah, by 3 over 3.
So,
So, by 1 over
it would be 1 over 3, 8 over 8.
It's even less? Oh my god. Reduce that. 1 over 3.
Okay. You have to be careful. Sometimes you don't want to reduce before you add, but sometimes you do. It's not a big deal, but it was something that was there. Okay, next up. And that's actually why I put it there. Now this one was evil. And it's actually the easiest one on the whole page. But it's the one that seems to cause, well, 4 and 5 are ugly. And people just look at that and go, oh, good Lord, I can't do that. But that's not right. They can do that. Just because it's, I mean, look, babies are born ugly as can be. We have to get over it, you know? Like, really, there's no such thing as a pretty baby. They're ugly. They're all ugly. Their heads are misshapen. Their color is weird. Ugh. Okay. Wait. How do I do, what do I need? Over 1. We have to change that into a rational number. Well, it is rational, but we have to write it as a rational number, as a ratio of integers. And now, well, isn't it going to be just like this? 8 minus 5 times, no, 15 times a squared bc squared over, yeah? That's it.
Yes. Wait, so you multiply 5 by...
Yeah, you need a common denominator. That's going to be your common denominator. Can't reduce it. There's no common factor between 8, 3, and 15. Do you see why this one was really, really easy?
Yes.
It didn't look easy, did it? But it is easy. Yeah. Because I let you guys try these on your own and you were making mistakes, that's why you're learning. If we went over this ahead of time, you wouldn't have learned. And that's why you guys are going to be successful. So you can't avoid problems. That's the moral of the story. You can't see it and avoid it. You have to make use of what you know. I will not give you things that are beyond you. You have to try them. You have to make mistakes. That's why students struggle with math is they don't want to try anything. They want to be told what's right first. And it won't help. Like, for example, last period, I showed them something, and then I on the clock, I watched, and 8 minutes later, I asked them the same question, and I made sure they all wrote it down. And 8 minutes later, I asked them the same question. You know how many students knew? 0. None. So, you got to be engaged in thinking. What's the common denominator between 3 and x? 3x. In Spanish, que simple is rude, but in English, it sounds like it should be like, oh, that's simple. Right? But in Spanish, that means you're simple. Kind of. Okay, so I have to multiply this by x over x, of course, and this one by 3 over 3, but I have to distribute to the whole thing, so it's going to be 5x cubed minus 2x squared más x. Oh, that's nasty. Oh, goodness gracious. That right there is what's going to cause you problems. We have to be careful with this. These are called rational expressions or algebraic fractions. If you're doing these and you see a minus sign, back the truck up. Slow down. Math is like dating. If you rush in, you're going to do something stupid, you're going to get your feelings hurt, and everybody's going to be like, I told you so. That's how it's going to work. So watch. This is really -1 times all of this and 3 times all of this. We're subtracting all of that. See, we're subtracting all of it. So really all of this is going to be -1 times the whole thing. So what I really want to do is I really want to do -3 times the whole thing. I'm just going to write it on top as scratch work. But you have to know why it's -3. That's the trick. Right, because you're subtracting it. Okay.
So the one part up there, it's also negative. Negative 2y.
Uh-huh. Oh, yeah, that's why it was -2y up there. Uh-huh.
So there's a...
And then minus 6x, and then mas, oh, well, this is x squared. Well, I know we're running out of room there. There we go. That was a nasty trick right there.
How can we write the -1?
Well, I just did it right here. That's why I multiplied by negative 3.
Yeah, but like if we just had that fraction counted, we write in the negative 1.
I don't know what you mean.
For like everything, how do we just put the 1 in front, negative 1 in front of the plus?
Well, you don't need to. It's just you're subtracting it. So when you're subtracting, it's adding the opposite.
Yeah.
So this is minus 5. That's the same as plus negative 5.
Yes.
Yeah.
So that's the answer.
Why would I do negative x right here?
Why wouldn't you do it to the other, the other
The-
side?
Over here?
Yeah.
Well, because this is positive. You're subtracting this. Yeah, you're subtracting the second thing. Like, that's how we write it. Yeah. The second thing's being subtracted. Okay. Subtraction is addition of the opposite. We are adding the opposite of all of these. So that's why this is really a negative 5, and this is a negative 2, and this is a positive 1. You're adding, that's what subtraction is. It's addition of the opposite. Yeah.
Where did you get that x? Plus x?
What plus x?
Um,
Right here?
yeah.
From here. You have to multiply this x times the whole thing.
Oh.
After you do, that's called distributing, right?
And is it negative times negative positive? So
Mm-hmm.
negative x times negative 3 positive 3?
Right, that's why it's positive 3.
Oh, okay, I hadn't seen that.
Yeah. After, this is called distributing, right? After you distribute, you almost always have to do that thing that begins with a C and ends with unbind like terms. Like, almost always. Right. Right, combine like terms, right. That's good, Jesus, that's good. So, like terms, we make that seem way more complicated. It's really the apples and oranges. X cubed and x squared are not the same. X cubed and x cubed are. So that's 5 and negative 15, so that's negative 10. And this is negative 2 and negative 6, that's negative 8. That's 1 and 3. I believe 1 plus 3 is 4. All over 3x. In holy moly guacamole, it can be reduced by x. A la bestia. So look, it's going to be x goes into x cubed 2 times, and that's going to be a 1, and that's going to be bye-bye. How do you x out an x? That doesn't make sense, does it? Look, I just tried to x out an x, and all I got is a different color x. Oh, I hate my life. I guess I should just go ahead and rewrite it. That's negative 10x squared minus 8x plus 4 divided by 3. Okay, shukis. Yeah. All right, boys and girls, we are almost out of time. You need to work on number 5, and then listen. Do you see on the cart right there? There's another worksheet. That's your homework. You should get one.